Okay, good. So I'll talk a little bit about what was earlier in the opening panel on how to build maps based on sensor data. So I think that's one thing that I'm really actively working on. And a little bit of background, I've been working on that very long. So I've been a co-founder of a OpenStreetMap-based navigation company called Scobbler here out of Berlin. And we've been last year acquired from Telenav, basically for our OpenStreetMap navigation assets. And what we've been working on really is like in order to like how can we get like the OpenStreetMap and maps in general to be like automotive grade so that it can be really used in cars, and what's really the next challenges for that. And I want to provide a little bit of background into that. So the very interesting thing is that the map landscape is really massively changing. So we've seen that historically, basically, there was like two big mapping companies. There was TomTom, and there was, at that time, basically Navtec, or Teleatlas and Navtec, which was now TomTom and here, basically. But nowadays, it's completely shifting. Nowadays, like a lot of technology companies understand that owning a map and having really a map is like a crucial asset to them. So we see that Apple has now their own mapping vehicles which are driving through the United States and other countries to set up these assets. Tesla has seen that they could only build the autopilot function of their cars because they start to build their own maps. So really every Tesla in the world is basically creating its own maps while it's going. And Uber was trying to buy here, but as they didn't succeed, basically they like set up their own team to create their maps and bought the mapping assets from Microsoft. And here was acquired by the German car makers because they don't want to be left in the background when Google is developing their own self-driving vehicles, because they understand that owning map data is key to having self-driving cars. And I mean, Google is of course the most ambitious of all of them. So they have stated very clearly, so Chris Urmson always says that like he wants to have self-driving cars in the road within 4 years in production so that his son doesn't need to make a driving license anymore. And all of that is powered by high precision mapping. So the most important thing to understand is that the map of the future is very different from what it is right now. I mean, basically if you look at a current map, then more or less it's like a digital transformation of the paperback map. I mean, it's still fairly static. I mean, the map doesn't really change. You maybe have a couple of layers like traffic, parking spots, as we've just heard in the presentation, other things on top of it. But fundamentally, it's still the very same map that we used to have in paperback format, now just in digital format with a little bit of more information. But in the future, the map is becoming a really much more critical asset to all the things. So first of all, there's a couple of big trends. So the one big trend is that the map is becoming dynamic. So what you see is, for example, things like dynamic speed limits. When you see on the motorway posted that right now you're allowed to drive 120 here, that's there. You see the dynamic information, even like the cycles of red light cameras are in there, so that you know exactly if you drive with this speed, then you will like pass the traffic light when it's green, and you will like save a lot of energy. So you see that also the infrastructure is communicating back to the map. So this is the dynamization of the map. And weather data and all this kind of things. The second big thing which you see is that the map is used for safety functions. So you see for autonomous driving, for eHorizon, basically a lot of safety functions rely on the map. So there, like, you need a very different precision than when you need normally for guidance. In guidance, when you say like turn right in 50 meters, it doesn't really matter if it's off by 1 or 2 meters. But if the vehicle uses the map to safely navigate you across the street, it's very critical if it tells you like this is like 1 or 2 meters off. So I think this is like the precision for these safety functions require often like 10 centimeter accuracy. And this is like if you consider that you have sensors like GPS who are very far from having 10 centimeter accuracy, then that's very hard to get, because like right now none of the location sensors that are deployed in large scales allow this 10 centimeter accuracy. So that's the second big thing that gets used for safety functions. And the third thing is also that there's really a big advent of new functionality that is used by that. So you see that like usage-based insurances or car sharing or so on rely on them. And they also have very unique requirements in terms of like how the maps function. So, and the most important thing which I want to say is that I think we've been like waiting for that for ages. So we've waited for maps to power our self-driving vehicles. And I think we're like always talking about this big visions, and the car makers say, yeah, 2025 we'll have like some self-driving vehicles. But I think then what happened this year, just a few months back, is because everybody was talking for the very long time. But now we see that Tesla is basically leapfrogged everybody and they just ignore all regulations and introduce their autopilot. And I want to, if you haven't seen it, if it would be online here, then I would show this video, but otherwise you'll take a look. But I can tell you, I tested it myself in California and drove with a Tesla with an autopilot, and the really big game changer is that what they did is, I think, exactly the same vision that we have. They make every Tesla car into a mapping vehicle. So even cash-rich companies like Google and Apple, they have maybe hundreds, or here they have hundreds of mapping vehicles which go all around the world and map it. So even in a really good situation, you might have that one of these mapping vehicles passes your address maybe once a year, twice a year, maybe 4 times a year if you're in a really, really high frequency spot. But you need to know that about 10% of the map information changes every single year. It's not that all the details change, but let's say from a street, the speed limit changes, a turn restriction changes, direction of flow changes. So that is true for 10% of all the segments in the map. So that means if you go only twice a year, what the big companies do, you have on average 5% of your map information at any given time is wrong. If you exclude anything that you map something wrong, just by this time effect, you have 5% is wrong by the time that the map reaches you, which is quite horrible. Of course, not everything will be wrong, but some information. And so what Tesla does with its autopilot, basically you see that the car senses its environment and then uploads this to the Tesla cloud. And people have saying that areas where the autopilot didn't work very reliably, after they drove past it 10, 20 times, suddenly the autopilot functioned. So this is the whole thing, that Tesla has now the most mapping vehicles in the world. It's not here, it's not Uber. Tesla has the most mapping vehicles. They have 100,000 mapping vehicles on the road. And that's really what the future of map creation is, when it's not anymore about this high-powered 80,000 euro LiDARs on top of the car, but when it's really about every car in the world creates this map. And I think the community have to really take part in something that's really transforming the society. And I think Tesla is quite bold with this. Also quite shocked because we almost crashed with our Tesla when we let it self-drive. But we hope that it would only crash once at that spot. So after we have crashed a couple of times, hopefully there will be no further Teslas crashing at the same spot because they're learning while they're driving. So on our case, this is kind of how we look the map of the future, and it has a couple of aspects. So on the one side, basically you have all the environment data. So you have the base layer of the map, which is the streets and the road networks and all that data. You have data from the real-time data from the driving environment. You have things like traffic lights, dynamic speed limits, and then you have data like parking availability and traffic, of course. So you have all this kind of environment data which will be fed into the car and which will be put on top of real-time, so that you exactly know where's the traffic at a certain situation, where's the traffic lights red, where there's parking available, as we just heard. So all of that is environment data. And then we have on the one side also personal data. Because the most important thing is while right now people use 10% of their driving time, they use navigation systems. Why don't you use a navigation system? Because people are always upset when you go from work to home, your navigation system delivers you the route that the navigation system thinks is the smartest route, but you have your own idea which roads you want to take. So that's why you don't do that. So what do we do, for example? We track where you're driving, and if you're really driving 10 times the same road, then in our navigation system we put a preference on it and say okay, actually our system thinks it's not the best road, but since you really believe it's the best one, we'll put our route closer to that, and only if there's really a big congestion or big incident, we route you around it. So one part is your personal driving. And then there's other things. There's your calendar, which tells you where to go at a certain time, your messages where you do other things, or your emails. So this is all your personal data, which we believe also belongs on there because it has a high relevancy to tell you when you need to go somewhere. And then we have the data out of the car. So fundamentally, we believe there's 3 big types of data that you need to get out of every car to make that happen. And Tesla has 2 out of them, but I think it's basically 3 big data streams that you need. So the one thing is you need to have a GPS in the car. So you need to have the position from the car in an as precise as possible way. So that's the most important sensor. So this is GPS-based probes, which you can use to track anything. The second big system which you need to have is camera. Because no matter how many probes you have, without a camera, some things you can't see. You can't see a house number based on a GPS position. If you have a camera, you can film it and you can record it. And then there's a third big sensor,
which is a lot of controversy around, which is a LiDAR sensor, which is basically the same sensor that you have in your Kinect, that you can build a 3D point cloud of everything around you. So I think this is also what you fundamentally need, in my opinion, to build a self-driving car. Elon Musk makes the point that you don't need that and it's too expensive. And I think, fundamentally you don't need it because we as humans have two eyes and we see, and obviously we can drive without having a LiDAR. So fundamentally it needs to be a solvable problem. But on the other hand, it makes it so much easier, and companies in Silicon Valley work now, like Quanergy, for example, works now to build a $50 LiDAR, and that just makes the problem so much easier. So then you basically have a full representation of where people drive, you have a full visual representation with camera systems of the world, and basically with a LiDAR you have a full 3D representation of everything, all the obstacles around you. And that's what we believe. If you have this data and all the cars are connected to the cloud, that's basically how you do that. So this is basically things that we already do. So I think we have systems with GPS probes where we see like, okay, this is like an existing road, and then basically when cars are starting to drive, then we see, okay, there's people driving, there's no road below it, so like flag it immediately, in this case, to the OpenStreetMap community and have it mapped. So that's the one thing. Then the second thing is like camera systems. So we have developed an image recognition technology. While you're driving, it films across the road, and then if it sees a speed limit, it compares it with the map data. If it's not the same, it uploads it to the cloud, and in this case, we also flag it to the OpenStreetMap community to fix it. This is a more research project, which we do with one of the car makers, where we do the same thing with a LiDAR. We try to like sense your 3D environment and then automatically detect if something is changing. So then we say like, hey, there's like a new rail line on the side, there's a new center line of the road. So basically all the same, right? You're always taking the same approach. You like the image, the vehicle in real time recognizes it, then compares it with the data that it thinks is reality, and as soon as there's a change, it flags it to the cloud, and all the other vehicles behind you map it automatically. So you can consider it as like the same thing as like ant intelligence, basically. So consider that if you're the first driver who sees a new situation, then you're like the ant who discovers something new, and you need to give that information back to the central hive, so that all the other vehicles after you don't have the same problem. Because what happens if the map data doesn't match reality, your self-driving car will either ask you to take over, or it will slow down, or it will behave in any other ways not optimal. Like the Teslas right now almost crashing, which is for sure not optimal. And basically this is like what we want to avoid, so that only one person has this problem and all the others coming behind him see that. So that's basically what we do. So I just want to give you like a couple of examples. So this is again the example with the GPS probes where we have also small animations. So this is how it looks like. We're on the web, we released a tool on Improve OSM where you can see like this is all where people are driving, where there's no road network, and then you can zoom in and then you see exactly that's where they're driving. You can put a satellite pictures behind it and then people can map it. So this is something that we'll like upload on a very regular basis, in this case to the OSM community, but of course the goal long term is to automatically map that. So there you can see that based on people's driving behavior, they automatically improve the map. So basically people get from like users of the map, they get to people who are improving it. And this is in production, so if you want to check it out, it's on improveosm.org, where we have released this tool and a couple of others. This is the second example which I mentioned earlier. So here we're putting speed limits on the map. So we're having like people driving all around in Berlin, and you can see like, okay, there's all this limits seen. So this is basically where our users have driven around with their smartphone, because it's very hard to get in cars. So we put a smartphone, you put it on your windshield, it films, then it recognizes the signs automatically, uploads it to the cloud, and we can do two things. One, if we have enough certainty, we can just automatically add it to the map, because we know, okay, 10 users have seen that, it's certainly there. Or if not, we can send it to the community, including the image, and they can map it. So that's also like where we are heavily working on to increase that for other signs, right? I mean, if you imagine if you have the camera, everything that you can detect, you can automatically add to a map. And this is then some things we're working on to recognize also like these kind of signs. So we're working also on OCR software that it can read, okay, if you want to go to Hanover, then you need to drive to the right side. So that's also really very, very fundamental information if you can imagine what can happen. So fundamentally, this is basically the vision that we have. So we call this the living map, because that's really where it changes. So we see like at the center of it, it's basically a big technology stack for like processing all this information. And then we give like tools and validation opportunities to the OSM community, which is in over 2 million members right now, which basically like enhance the map for everybody, not only for us. And on the other side, we deploy these changes with Delta updates to our vehicles because it's quite fundamental that they really get all those changes. So we work on technology that not like traditional map making only delivers you the map like every few weeks or every few months. And we're working on technology which will be live in 2016 that allows us to do minutely map updates to all the drivers. So basically all the cars will get like every minute when all the swarm of other cars see something, they get a new map, basically match it, and then like still detect the deltas and upload this back to the crowd. So this is, I think, how we see like the future of mapping and geo information, that you really have the cycle of like people who create the map and people who use the map, and they're basically living in symbiosis. In the past, you had like really, here does your map, and the car makers use it, but fundamentally in the future, we'll get one big circle, and that will enable really to take the map to a whole different quality level. I mean, that's the big goal, to go down from this like 5% error rate that you just statistically have if you go like twice a year, down to a much, much lower rate, where basically every error that you have or every new construction that you have is detected within like maybe hours or maybe in the future even minutes, if you have enough vehicles. And if you imagine that we are like talking about an order of like a couple of orders of magnitude increase, if you say that like somebody has right now maybe 100 mapping vehicles, and if you see that the big car companies sell like 10 million cars and you equip them all with the sensors, then suddenly even what Google is doing right now with its mapping efforts in production looks like kindergarten, because now you like deploy like thousands of times more vehicles in the world who are able to build these maps. So, thank you very much.